Pi is 3.14159265, but you came here for Pocket Ronnie, so please stay tuned.
Okay, we're going to be doing fractional exponents. As of now, you have seen this, 9 squared. You know that 9 squared equals 9 times 9, which is 81. 9 squared is 81. The opposite of squaring something is square root. So the opposite of squaring is square root. So it's like the reciprocals of each other, or I wouldn't call it reciprocals, but the opposite. So since square is opposite of square root, then we can take the reciprocal of this exponent. The reciprocal of 2 is 1/2. So 9 to the 1/2 is the same thing as saying the square root of 9. Whenever we have fractional exponents, the denominator tells you what root you are doing to the number. Are you doing a square root, a cube root, to the 4th root? The numerator tells you what power you are raising it to. So this 2 tells me I'm doing the square root, and I'm raising it to a power of 1. So I can rewrite this as the square root of 9 raised to a power of 1. When we do the square root, we do not write any number right here. As a radical with no number is automatically assumed to be the square root. So 9 to the 1/2 is saying the same thing as a square root of 9 raised to the 1st power, which is the square root of 9, which is 3. Okay, now here we have 8 to the 1/3. Remember what I said, the denominator tells you the root, which root you're taking. Are you doing the square root, the cube root, the 4th root? So this denominator tells me I'm doing the cube root, and I'm raising 8 to the 1st power. So I can rewrite it as cube root. When you have a radical and then there is a number, let me write it a little bit bigger. When you have a radical and then there is a number right here in the radical, that tells you the root. This tells me I am taking the cube root. It is no longer square root. I'm taking the cube root. And that numerator tells me I'm raising 8 to the 1st power. So I'm taking the cube root of 8 to the 1st power. 8 to the 1st power is still just 8. The cube root of 8 means what times itself 3 times will give me 8, and that is 2. 2 times 2 times 2 is 8. The cube root of 8 is 2. Again, the cube root meaning what times itself 3 times gives you 8. 2 times itself 3 times gives you 8. So just to reiterate, if I didn't use any numbers and I just used letters like in algebra, x to the 2/3. The denominator tells you what root am I taking, square root, cube root to the 4th root. In this case, I'm doing cube root. The numerator tells you what power you're raising it to. So I'm raising x to the 2nd power, x squared. So if I want to rewrite this in radical form, I can rewrite it as cube root with my radical and a 3 right there. That means cube root x squared. I'm raising x to the 2nd power, x to the 2nd power, but I'm taking the cube root of that. This fractional exponent and this radical form mean the same thing. In other words, x to the 2/3 means the same thing as taking the cube root of x squared. These two mean the same thing. Alright, now let's work some problems with these. Let's go to 31b3. 81 to the 1/2. Remember, the denominator tells you what root you're doing. The numerator tells you what power you're raising it to. So if I want to write this in radical form, this means I'm going to write it as, this denominator tells me I'm doing the square root of 81 raised to the 1st power. Well, 81 to the 1st is still just a square root of 81, and the square root of 81 is 9. So essentially, anything to the 1/2 means the square root of that number. 81 to the 1/2 is the same thing as square root of 81. Now go down to 31b, number 8. We're doing 27 to the 2/3. 27 to the 2/3. Denominator tells you what root. I am doing the cube root. So I put a 3 right there. I'm doing the cube root of 27 squared. Okay? So this means the cube root of 27, then I want to square it. I like to do the cube root first. Okay, I can do it like this. I can say, I usually do the root first. You can square it and then do the cube root, but I like to do the root first. So I do the cube root of 27 first. And so I think, what times itself 3 times gives me 27? The cube root of 27. What times itself 3 times gives me 27? And that would be 3. So the cube root of 27 is 3. Because 3 times 3 is 9, times 3 is 27. So the cube root of 27, here, actually we should probably write it this way. Write it like this. The cube root, there we go. Then we're doing the parentheses first. The cube root of 27 squared. This is a better way to write it. So we can do the cube root of 27, which is 3, and then we still want to square it. So we did in our parentheses the cube root of 27. Now we want to square it. So the cube root of 27 is 3, then squaring it is 9. Let's jump down here to 31b4. Remember, our denominator tells us what root we are doing. So I am doing the 4th root of 625, and then I'm going to raise that number to the 3rd power. The 4th root of 625. So the 4th root of 625 means a 4 goes right there. I'm going to do that, and then I'm going to raise that number to the 3rd power. So I have to ask myself, what times itself 4 times gives me 625? Well, it's got to be a small number. What times itself 4 times? 5. 5 times 5. 5 times 5 times 5 times 5. Now that does not mean 5 times 4. 5 times 5 times 5 times 5 equals 625. 5 times 5 is 25. 25 times 5 is 125. And 125 times 5 is 625. So, to think backwards, what times itself 4 times is 625 is just 5. The 4th root of 625 is 5. And now I still want to cube it. So, that's where my cube goes in right there. So 5 cubed, 5 times 5 times 5 is 125. Alright, now let's look at 31b11. What else can we do with fractional exponents? Okay, what we just did was to learn what does it mean to have a fractional exponent. What does that denominator mean? What does that numerator mean? Now let's take everything that we've learned in algebra and now put it all together. Okay, so we have 16 to the 1/3 raised to the 3/4. When you have an exponent raised to an exponent, what do you do with those exponents? You multiply them. So these exponents get multiplied. An exponent raised to an exponent gets multiplied. I could do the parentheses first, 16 to the 1/3. That means the cube root, the denominator tells you what root. That means the cube root of 16 raised to the 1st power. Anything raised to the 1st power is itself. Well, I cannot take the cube root of 16. There is not it would be a decimal. It would not be a whole number. So there's no whole number because 2 times 2 times 2 is 8. 3 times 3 is 27. Well, 16 is in between those two numbers. So there is no whole number that is the cube root of 16. So instead of doing this, doing it that way, doing my parentheses first, then I'm going to look at what else can I do in the laws of math. If I have an exponent raised to an exponent, I can multiply those exponents. So instead of doing the parentheses first, an exponent raised to an exponent, you multiply those. So if I have 16, 1/3 times 3/4, do you see how my 3's cancel? One's in the numerator, one's in the denominator. Multiplying those exponent gives me 16 to the 1/4. That is the same thing as saying 16, the 4th root of 16, all raised to the 1st power. The denominator tells you what root you're doing. The numerator tells you what power you're raising it to. Now I have to ask myself, what times itself 4 times gives me 16? That's got to be a pretty low number. So I always think of 2. If I have an even number here, I think of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 times itself 4 times gives me 16. Raising 2 to the first power is still just 2. Alright, let's look at 31B13. Now we're taking what we know and we're just using letters with the world of algebra. Okay, when you have letters raised to a fractional exponent, obviously you can't get a number out of it. So you just have to ask yourself, how can you simplify this with everything that we know? So if you have the same base and you are multiplying, or if you have the same base and you're multiplying your bases, what do you do with your exponents? Before, what we did is we added our exponents. The same is true even though we have a fraction. You add your exponents and you do parentheses first. So this is y adding your exponent 1/2 plus 3/4. I still have my 4/1 out here. I'm just going to ignore that for a second. When I add fractions, what do I have to do? I have to make a common denominator. So make a common denominator. So 1/2 plus 3/4. I need a denominator of 4 right here, so I need to multiply both of those by 2. So this becomes y to the 2/4 plus 3/4. Now I have a common denominator. So now I can combine my numerator. So that would be y to the 5/4, still raised to the 4/1. Now when I have, so I did PEMDAS, I did my parentheses first. I've simplified my numbers together by adding my fractions. Now I have y to the 5/4 raised to the 4/1. I have an exponent raised to an exponent. What do I do with those? Now I multiply. When you have an exponent raised to an exponent, you multiply. When I multiply, do you see how my 4's will cancel? So multiplying everything out would be y to the 5/1. Or we can just write y to the 5th. Okay, now we're looking at 31B15. Here we have x to the 4th raised to the 3/5 raised to the 1/6. The rules of math are the same no matter if your exponent is a whole number or a fraction. So we have an exponent raised to an exponent raised to an exponent. What do you do when you have an exponent raised to an exponent raised to an exponent? You multiply. So you can just multiply all of these numbers together. The main thing is to turn this, since you have fractions here, turn this into a fraction. How do you turn any number into a fraction? By putting it over 1. So essentially we have x to the 4/1 times 3/5 times 1/6. You can multiply them in any order because multiplication is commutative, so it doesn't matter what order you multiply these in. I would look to see, since you're multiplying, when you are multiplying, you can cancel. Only when you're multiplying can you cancel, not adding. So here, you can cancel this 3 and 6, so that becomes a 1, and this becomes a 2. Now this 2 can cancel with the 4. That cancels to be 1, and that becomes 2. Keep up with your canceling. If that bothers you to cancel, then just multiply it all straight across. Okay? So now it's just multiplying straight across. So this became 2 times 1, which is 2. This became 1 times 5 is 5, and 5 times 1 is 5. So when you cancel, everything is already reduced. Let's just say you didn't cancel it ahead of time. Then you would have x to the 4 times 3 is 12. 12 times 1 is 12. 1 times 5 is 5. 5 times 6 is 30. You would have 12 to the 30th. Then you would just need to reduce. Okay? You can reduce both of these by 6. And that would be to the 2/5, which is the same answer that you get when you cancel. So you can do it either way. The main thing to know is that all of these exponents need to be multiplied together. Now let's look at 31C number 7. We have y to the 2/3, parentheses means times. Y to the 2/3 times y to the 1/4. We have the same base. We're multiplying the same base. What do we do with our exponents when we multiply the same base? We add them. This is not anything different than when we did not have fractional exponents. Now we just have fractional exponents. So you add your exponents, 2/3 plus 1/4. What do you do when you add fractions? Make a common denominator. Do not forget that. Make a common denominator. I just write CD. So we need a common denominator. What is our common denominator going to be? 12, which means we need to multiply this fraction by 4, and we need to multiply this one by 3 in order to get a common denominator. So my new fractions are multiplying this fraction by 4 for the numerator and denominator. My new fractions becomes 8/12. Multiplying this fraction by 3 to get a new fraction would be 3/12. When you add fractions, you only add your numerator, so that becomes y to the 11/12. Always check, can I reduce my fraction? I cannot reduce 11/12, so that is my final answer. Going down to 31E6, I have 3 to the 1/2 times 27. Do I have the same base? No. And we're not going to put this 3 to the 1/2 means the square root of 3. The square root of 3 is not a whole number, it's a decimal, and we're not going to put our answers in decimals. They're not wanting you to work it that way. So the way you need to work it is by putting this, you ask yourself, can I put this number into the same base as this? My base is 3 here. Can I turn 27 into a base of 3? So I'm going to leave 3 to the 1/2 with that base. But I can make 27 if I put it in the base of 3. 3 to the what is 27? 3 cubed. 3 times 3 is 9, times 3 is 27. So 3 cubed is 27. I'm going to turn 27 into a base of 3. Now my bases are the same. When I have the same base and I'm multiplying, what do I do with my exponents? I add them. So this becomes 3 to the 1/2 plus 3. Do I have the same denominator? No, because this is like 3/1. When I add fractions, what do? Make a common denominator. Make a common denominator. I want my denominator to be 2. So therefore I need to multiply this fraction by 2. So this becomes 3 to the 1/2 plus 6/2. 6/2 is the same thing as 3/1. Now I can combine my numerators, which becomes 3 to the 7/2. Leave it as an improper fraction. Do not change your exponents to a mixed number. So, and we can't reduce 7/2, so we leave it just like that. And only when you can change it into another number do you put it into a radical form. Because what this means, this is the same thing as your denominator tells you what root. So I'm taking the square root of 3 raised to the 7th power. So square root of 3 is not a whole number, it's a decimal. And then I'll be taking a decimal raised to the 7th power. But in this book, they're wanting you to leave the answer in a fractional, they're wanting you to leave the exponent in a fractional form, not in radical form. But these two things mean the same thing. 3 to the 7/2 means the square root of 3 raised to the 7th power, but we're going to leave it in this form since we cannot change square root of 3 into a whole number.